So here is a question that was set by OCR as a specimen question a couple of years ago, and it's about squirrels. In a certain region, the populations P, G, and PR of grey and red squirrels at time T years are modelled by these equations. So the population of grey squirrels, the population of red squirrels. And so over time, the populations are going to change. T is bigger than or equal to 0, and K is a positive constant. So we've got to sketch the graphs of PG and PR on the same axes. So first of all, let's look at the population of grey. And what I'm going to suggest we do is that we ignore the constant K and just take some values of T. And I'm going to use the values of T equals 0, 1, 5, and 10. So we're using that equation for the population of grey. So we're going to put 10,000, open brackets, 1 minus, put that there, E, which of course is found there, to the power minus 0 for our first one, close brackets, equals, and that gives us 0 there. So we're going to go back now to there, delete that one and put 1 equals, that becomes 6,321. We'll only use the whole numbers, so we'll ignore the decimal part. Let's go back again, delete that, and we'll put 5, and that's now 9,932. Sorry, if we go back then, delete that, and put 10 in. And now we're on 9,999. So we look like we're getting close to 10,000. Let's try the same with the red squirrels. So we'll clear this, and we'll put 20,000 E to the minus 0. That's the 20,000 we're starting with. Okay, so now we're going to go back, delete, and we're going to put 1, and that's now 7,357. Let's go back and put 5, and that's now just 134. Now let's go back and put 10, and that is 0.9. So our job was to sketch the graphs of PG and PR on the same axes. So I'm going to suggest that it looks something like this. There's 0. The reds started on 20,000, so we'll put 20,000 up there. We'll put 10,000 there. And if we look at the greys, that's this one, PG, that's this one. At 0, it was 0, so it started there. Then it's gone to 6,321, then there, and then it's heading towards the 10,000. So I'm thinking it's something like that, where that line is the 10,000. So we'll put a dotted line across there. And the 20,000 has gone down, and it is heading towards 0. Oops. So somewhere like that. So there's the sketch. Now give the equations of any asymptotes. Now an asymptote is a value that gets closer and closer but is never actually reached. So for the grey squirrels, I think PG is 10,000 because it's kind of hovering around the 10,000 area. And for the red squirrels, the asymptote is 0. So that's the first part, question 1, parts A and B. Here's the next part. We've still got the same equations. What does the models of these models, what do they predict about the long-term population of A, grey squirrels, and B, red squirrels? And all we need to do is to write a sentence to say the long-term population of grey squirrels is likely to be approximately 10,000, and the long-term population of red squirrels is likely to be 0. There's the models again, and then we've been given extra information. Grey squirrels and red squirrels compete for food and space. Grey squirrels are larger and more successful. Comment on the validity of the model given by the equations, giving a reason for your answer. So all we simply need to do, it's a 1 marker, all we need to do is again to write a sentence along the lines, the grey squirrel population increases as expected because they are larger and more successful, and the red squirrel population decreases as expected. So this part, question 4, show that according to the model, the rate of decrease of the population of red squirrels is always double the rate of increase of the population of grey squirrels. That's an interesting idea. So because we're talking about rates of decrease, we're looking at differentiation. So let's look at this one first. So we know that the population of greys is given by that there. So I'm going to multiply that out. So that's 10,000 minus 10,000 e to the minus kt. Now if we differentiate that, d to the pg over dt, that bit's going to go. And this bit, we're having to differentiate an expression with e in it. And so what you do there, you may remember from the chain rule, is that we write the whole expression and then we multiply it by the differential of that bit. So we differentiate that bit to times that one. So that differentiated in terms of t is simply minus k. So we end up with, minus times a minus is a plus of course, 10,000 k e to the minus kt. Now if we differentiate this one, we've got dpr over dt is going to be equal to 20,000 e to the minus kt, so the expression itself multiplied by the differential of that one, which is minus k. So that ends up as minus 20,000 k e to the minus kt. And you can see, I'm just going to move that up a little bit. If we compare these two, that one is increasing because it's positive, that one is decreasing because it's negative, and you can see that it's exactly double. So we can say, therefore, the rate of decrease of red squirrels is double the rate of increase of grey. So now, at long last, we're going to find out what k is, because it's telling us, given that the numbers of grey and red squirrels are equal when t equals 3, find the value of k. So after 3 years, the numbers are equal. They're changing, of course, with the greys rising and the reds falling. So what we know then is that 10,000 times 1 minus e to the minus 3k, because t is 3, is equal to 20,000 times e to the minus 3k. Didn't really need those brackets, but hey. If we multiply this one out, we'll get 10,000 minus 10,000 e to the minus 3k equals 20,000 e to the minus 3k. You can see we can add that value to both sides. So 10,000 is equal to 30,000 e to the minus 3k. So we could just simply swap sides. Let's move that up. 30,000 e to the minus 3k is equal to 10,000. And obviously then for e to the minus 3k is equal to 10,000 over 30,000, which is 1 over 3. The minus 3k is equal to the natural log of 1/3, which means that k, if we divide both sides by 3, is minus 1/3 of the natural log of 1/3. And if you put that into the calculator, minus 1/3 ln and you see that comes out as 0.36623 decimal places. There we go.